All right. Good evening. My name is Alessandro Barbieri. I'm head of product management here at Pluribus. I'm going to switch gear. No more fancy CLIs or weird features from the special switch. I want to show a couple of things. First, how we go to market with this platform. How do we package actually Netvisor? I'm going to keep it simple. How do we package? How can you consume as a customer this platform? And then if we have time, I'm also going to cover some of the use cases which we feel are more repeatable or the most common use cases across our customers. There's also a section on deployment models, but probably I won't have time to cover that. So first of all, this is sort of a stack diagram of our OS when it runs on powerful appliances on my right, and when it runs on, let's say, canonical ODM top of rack switches. I call our appliances converged services switches. And when it runs on these platforms, you can see in red is really the applications we're trying to bring on top of the traditional L2, L3. We run, of course, our kernel level drivers for the chip to control the chips with all the properties Sunay described. And then on top of it, we build the fabric cluster, the analytics, the virtualization, the tunnel orchestration, all these applications which effectively are just modules of these operating systems on top of L2, L3, VXLAN, the traditional protocols, which of course are required to fit into the network. As you move to the left-hand side of the picture, you have a sort of a skinny-down version of Netvisor. It can be compiled as a distribution of Linux, and you're going to see some interesting stuff coming out from Pluribus in that space. And when it runs on a white box, effectively is your distribution of choice of Linux. Well, of course, we're going to have our own, but we can compile it pretty much with any distribution of Linux. And what you will lose effectively is just the server side, the capabilities tied to virtualization, tied to the zones, the storage capabilities we have on the higher end platform. So you will be able to run the fabric, you will be able to run the cluster, the analytics, the virtual flow technology, the tunnel orchestration, but perhaps you will lose some of the services and virtualization capabilities tied to the higher end platform and the Netvisor OS we ship with the appliances. So really, two ways of looking at Netvisor. One is conventionally packaged into a traditional switch, and the other is more unlocking all the power of the server switch architecture with all the virtualization and server-side features of the OS. At the end, though, it doesn't matter what hardware you're running on. Think Intel or AMD. We can run on today Intel and Broadcom. And it doesn't really matter with which operating system you're compiling Netvisor. It can operate equally on Linux or Open Solaris as well. The way we go to market is actually, I'm using this sort of visual matrix. So we look at three ways of consuming hardware and software in networking. One is a traditional box model, right? The hardware plus the software. This is what we source from Pluribus, the appliances you can see here at the office. Then there's more of a bright box model. It's you disaggregate hardware and software, right? This bright box, the term created by Gartner. It's a model where you disaggregate hardware and software, yet you have one source, one throat to choke, if you will, one vendor you're referencing to that does the integration, distribution, the packaging of both hardware and software. For us, today, this is Supermicro, and we're moving into other interesting partnership as the year progresses. And third, the last model is the true white box model, right? Where you have customers, namely the tier one cloud providers that we all know. There are probably 5 or 6 in China, 4 or 5 in the US. There are not many players in this space. Very specialized software, very specialized hardware, and they typically do the integration themselves. They don't rely on a third-party vendor to provide the integration aspect of hardware and software. In the first type of area, we believe actually we can serve cloud providers, private cloud, and enterprise customers. This is actually our top 3 markets right now. And this is where we are going to continue going to market with our high-end or high-performance server switches. You have seen the appliances we discussed early on. On the bright box model, we're going to partner with hardware vendors. I mentioned Supermicro as an example, and this is a great opportunity for us to leverage the channels, the scale of our partners, and attack the tier 2 cloud providers, enterprise private cloud, and of course also canonical enterprise customers. In the white box space, this is very much an ad hoc type of engagement with these customers. We have a POC going on actually in this space with a very large provider. This is about giving them an Netvisor with their own software on their own hardware, right? Extremely customized. It's not something we can even be discussing or too openly, or even actually too leveraging for other customers. This is very much an ad hoc type of engagement, a special hardware and special OS, everything heavily customized. Our portfolio is divided into 2 classes of product. We have the top of rack switches, or lift switches, if you will. We have a 1U switch based on Broadcom, and we have a 2U switch based on Intel. Those are some of the applications you can load on these platforms. The 2U box is a lot more expandable, can give you time machine capabilities. You can also run in some limited form firewalls and different applications on that platform. But you can see that we offer analytics as a package, fabric as a package, virtual networking or segmentation as a package, and also dynamic VLAN orchestration as a package as well. On the higher end platforms, I call them converged services spine, because ideally you want to offer 2 of these switches at the spine and then build a pod perhaps with 8 to 16 to 24 top of rack switches or racks, but those are really the 2 services spine offering services for the entire pod. Here you can also run, of course, the analytics, the virtualization, the tunneling, but we can also run a full open stack distribution to control hundreds of nodes fully integrated into the platform. We have 2 variants, a 40 gig variant based on a Broadcom Trident 2 chipset, and then we have more focus towards 40 gig aggregation, and then one more focus towards 10 gig aggregation with high density services capabilities, because we have very high compute capabilities on this product line, and storage capabilities as well. Interestingly enough, we also have another chipset I didn't mention into these appliances, a chipset from Marvell, performs a network processor type of functions. We use it for high-end type of QoS, like a TMQ manager, and also for DPI type of capabilities. We have a couple of customers using this also for exactly DPI type of capabilities. Very interesting, sophisticated use cases to parse packet all the way down within the first 230 bytes of every frame.
When is that available? Is that available now?
It's available now. We have it on, there are 2 models out of this product line, the F64 product line, capable of these 3 models actually, these 3 models, and then this model is also available as an option. Okay, so any questions on how we go to market, what is our portfolio? It's kind of simple, but I just wanted to level set. We have some application, few appliances, leaf and spine, so to speak. The spine are really converged appliances, because from the spine we would really want to run the services. The premise here is that you can build a pod very economically using, let's say, commodity switching economics on our entry-level server switches, and then you use the spine to really supply the services. And there are only a couple of those, or maybe 4 or 6 of those, depending on how you build your pod in the entire infrastructure. Really quick, I think I have 3 minutes here. There are 3 use cases which we have been we find ourselves more and more with our customer. Those are the most repeatable. One is a use case which you've probably seen also from other switching vendors. It's I call it here the analytics appliance. It's the packet broker use case. Here we are not running the network, right? We're just taking tap ports or mirror ports off of the network, the main network, and then delivering through tap aggregation, mirroring aggregation capabilities.
Are you seeing people using Pluribus specifically for that model?
Yes, we have 5 POCs going on for that, and the reason is very simple. They tried other solutions, right? Everything works well. That's fine. The problem is typically there's a demarcation point between the owners of the tools, the security team, and then the owner of the network infrastructure. This guy, the NetOps team, typically is in charge of building a network just to move packets towards the security team, and then they have no visibility into what's going on into the security team. At least they said, hey, we might as well buy a Pluribus switch, which is a cost, the fraction of one of those FPGA-based switches from the traditional packet broker vendors. And as the traffic goes through your switch, at least we have the full visibility, all the connection analytics we have seen before. I call it an intelligent packet broker, right? Or an analytics appliance. You can map all the application, look at all the client-server conversation, and we can do this with traffic that is effectively out of band from the main network. It's a very good use case because it's frictionless for us. This is your Cisco network. We don't touch it. We just insert, add value to it. It's a complementary play. And more and more, I think we're finding ourselves into this. We have about 5 customers, actually 5 customers in POC with that. Compared to traditional packet brokers, you have all our analytics value on top of it. You can track all client-server connection, look at application flow analytics. You can do packet capture. A packet broker just moves packets, bits and bytes, right? We have the time machine capability. And of course, we have also full layer 2 switching capabilities. Some other vendors, either they operate in tap mode or in L2 mode, switching mode. We actually can do both things. And then, of course, you can filter. We have the vFlow capability to write all these filters to select what traffic goes to the different tools, monitoring tools, application tools, security tools connected to the fabric. And, of course, we do mirroring and tap aggregation based on what the ASIC, the chipset, makes available to us. A more elaborate use case is when, of course, but kind of obvious use case is now you bring those analytics into a fabric. This is actually customer liking the idea of managing this fabric as a single logical switch from an operational standpoint, and then looking at the analytics is really the killer application for most of our customers, right? The connection application flow analytics, the ability to capture entire flow, the vPort capabilities, the time machine capabilities. This is all value add on top of this sort of a software-defined fabric, if you will, right? Everything canonical merchant silicon switch hardware, and then this fabric is all a software construct that builds on top of it, sort of a cluster type of technology. And last, you take your fabric and you segment it into multiple slices. This is a case of network virtualizations. We have customers actually running tens of virtual routers, and each virtual router is dedicated to a different application team in the network. Everything fully isolated, fully virtualized, and really with the concept of virtual routing. Routing as an instance. Every appliance can have his own routing, his own VNets, and his own services associated to it. Segmentation, live migration, geocluster, workload mobility. We find all these use cases be very applicable to this technology. I think I have nothing else, unless there are any questions.